Biocatalysis is the application of an enzyme or host cell to catalyze a reaction. Living organisms are often only capable of living in mild conditions in terms of temperature, pH, and chemical atmosphere, which indirectly results in safer and more environmentally friendly processes. Essentially, a catalyst is responsible for lowering the activation energy of a reaction, which in turn increases the rate of reaction. The class of enzymes we focused on are the amylases. Amylases can be divided into three different classes: alpha, beta, and gamma. Today we'll be focusing on just alpha amylase and glucoamylase and their application in the food industry. Both enzymes can be made by a process called solid-state fermentation, which is different from traditional fermentation through having no free-flowing liquid. Solid-state fermentation usually involves an insoluble waste biomass such as babassu for glucoamylase and sunflower or canola for alpha amylase, often obtained as a byproduct of food processing, which gets pulverized into smaller substituents. The substituents then get hydrolyzed and fermented using solid-state fermentation. The fermented product then gets separated and purified.
Solid-state fermentation leads to green can by helping manage the accumulation of solid waste by involving them in processes they are used for. Solid-state fermentation is being highly implemented in the green can industry, as produces little liquid effluent and has an incredibly high yield, whilst being relatively low energy expenditure and also lowering the risk of bacterial contamination. The main differences between these enzymes is where they react and how they are used. Alpha amylase is primarily an endoamylase, whereas glucoamylase is an exoamylase. The similarities between alpha amylase and glucoamylase are that they both hydrolyze starch, reduce stalling, improve the quality of bread, and are involved in the production of fructose and glucose syrup. Alpha amylase are responsible for the hydrolysis of starches and can work from anywhere within the starch to reduce it to glucose and maltose. It has such extensive application within the food industry, such as brewing.
As starch is used in the production of fructose and glucose syrups, there are three steps involved. These are gelatinization, liquefaction, and saccharification. Gelatinization is where starch dissolves in water, which forms a viscous starch suspension, and alpha amylase is dispersed in the water. Alpha amylase will then partially hydrolyze starch into short-chain dextrins, which reduces the viscosity of the suspension. This is the liquefaction step. The final step, saccharification, is where the glucoamylase cleaves the alpha-1,4 glycosidic linkage from the non-reducing terminal, and along with pullelamase, it yields high glucose syrup, which can be converted to fructose via glucose isomerase. Starch hydrolysis was previously done via acid hydrolysis, but this had many drawbacks, such as the equipment needed to be resistant to corrosion, and the high temperatures would also inactivate the thermolabile enzymes. Therefore, enzymatic hydrolysis is preferable. Similarly in baking, alpha amylase hydrolyzes starch into small dextrins, which will be further fermented by yeast. This will increase the rate of fermentation. Starch hydrolysis will also decrease the viscosity of the dough, which will improve the texture and volume.
Glucoamylase and alpha amylase can work together to achieve remarkable efficacy in ethanol production. In this process, ground corn kernels are blended with water and alpha amylase to hydrolyze starch into smaller sugar chains at 90 to 100 degrees Celsius. These fragments are then saccharified to glucose by glucoamylase at 50 to 60 degrees, and the resulting glucose is then converted to ethanol at room temperature. The existence of these two enzymes highly reduces time and energy cost in the production and has been widely used nowadays. Glucoamylase and alpha amylase are also used as anti-stalling agents, which helps improve the shelf life and allows baked goods to retain their softness.
The advantages of using enzymes in the food industry is that they can replace synthetic chemicals in many processes. They are also very specific, meaning there will be fewer side reactions occurring and fewer waste byproducts. This would give higher quality products and reduce the likelihood of pollution. This would also allow impossible reactions to occur. Thus, that's the use of alpha amylase and glucoamylase in the food industry. Thanks for tuning in.